The next exercise that we discuss is exercise 10.3. And 10.3 again brings us a very particular production function, as you can see. So here the production function Q is, the function is a minimum function, the minimum of 5K and 10L, which means that either capital or labor can really serve as a bottleneck in your production process. If you have a lot of labor but not a lot of capital, then your output will be solely determined by the number of units of capital that you have in place. And what we need to do is calculate the firm's long-run total, average, and marginal cost functions. And we will do so. And the thing that you need to realize is that, let's first draw some isoquants to make the problem very visible to us. So taking this production function, you can see that if, for example, you want to produce 50 units, then you need 10 units of capital at least and 5 units of labor, because 5 times 10 and 10 times 5 is both 50. And that's the isoquant that is drawn here. And this is at the kink we have 5 units of labor and 10 units of capital in place. And it doesn't pay off to install extra units of capital if you don't at the same time also install additional units of labor, because labor will serve as the bottleneck. You can inflate K whatever you want, but as long as you stick to 5 units of labor, then 10 times 5 will remain 50, and your production, which is the minimum of the two, will remain 50 no matter what. So this is something that you will never do, be here, because it only increases the cost of production without increasing the actual output. And I've also denoted some other isoquants here. Here is the one associated with an output of 100 units, here with 150. And you can see that all these isoquants are these very kinked isoquants. So in the long run, no input should be wasted, so you will never, in the long run, have units of capital in place that don't lead to extra production. And you also will not hire extra units of labor that you don't use, that don't actually serve to increase output. So you will never be here, you will never be here. You will always, in the long run, be at the kink. So in the long run, you will be at a point where 5K is exactly equal to 10L. Then the two terms here within parentheses are equal. So Q will also be equal to 5 times L and 10 times Q. Now you can rewrite this, because you can rewrite this as capital and labor, the contingent demand for capital and labor as a function of your output. So your number of units of capital will be equal to your total output divided by 5. And your total number of units of labor will be equal to total output divided by 10. So important, so the cost function is minimized at the kink. That's the lowest cost at which you can produce the given production of Q. So the expansion path of this type of production function is simply, it starts in the origin and then it's a straight line right through all the points where the isoquants have a kink. Important note, so realize for this type of production in the long run, inputs are used in fixed proportions. Here the ratio is 2:1. So taking the derivatives of the production function and computing the rate of technical substitution, that really doesn't help us here, because we are at the kink and there is no such a thing as a rate of technical substitution here. And this derivative is undetermined at the kinks. So what we do simply have, as said, is the contingent demand for capital is the derivative of the cost function with respect to the cost of capital, which is Q over 5. And for labor, the contingent demand is Q over 10. And that's exactly the expression that we have over here. And these are the contingent demand function, as they are denoting the amount of capital that you need as a function of the wage rate, the cost of capital, and Q. And as you can see, the expressions here are only a function of Q, and the cost of labor in capital, V and W, don't appear in the contingent demand functions. And this is because there's no substitution possible in this case. So if you, for example, would increase the cost of labor, so you would increase the wage rate, normally in your production you would substitute away from labor and you would start to use more capital. But given these kinks, no substitution possibilities are available, and your amount of capital is insensitive to the cost of labor. So the W doesn't appear here, and also the V doesn't appear in this expression. And that is because of the absence of substitution possibilities. Okay, so knowing this, determining the cost function is easy because the total cost is given by the wage rate times the number of units of labor that we need to achieve a certain production level Q, plus the cost of capital and the capital that we need to attain this production level. So we simply replace the contingent demands by the expressions Q over 5 and Q over 10, and we get a neat expression in terms of V, W, and Q. And of course, the V and the W appear here because if you increase the wage rate, then your cost of production will go up. And given that we have the cost function, then the remainder of question A is very simple because we need to find the average cost function, which is the total cost function divided by Q, and the marginal cost function, which is the total cost taking the derivative with respect to Q. And we arrive at the expressions that are given here. That completes exercise A. Now we're ready to do exercise B. And like in the exercise 9.2, we suppose that K is fixed at 10 in the short run, and we need to calculate the firm's short run total average and marginal cost function. So that's not difficult because we can just replace the K's in our expression for the production function with the given value of 10. We arrive at Q is 50, the minimum of 50 and 10 L, which gives us two situations. If L is smaller than 5, then the number of units of labor that we have will determine the total output, because for L smaller than 5, the production output will be determined by 10 times L, because it will always be smaller than 50. So in that case, Q is equal to 10L. The contingent demand for labor is Q over 10, and the total cost is equal to the wage rate times the number of units of labor that we use, plus the number of units of capital, which is fixed at 10, times the cost of capital, which equals V. In the other situation, we have more than 5 units of labor in place. Then the bottleneck will be formed by our 10 units of capital, because whatever our value of L then will be, the total output will be equal to 50. So in that case, our cost function will be equal to whatever number of units of labor we have in place times the wage rate plus 10 times, because our capital is still fixed at 10, times the cost of capital equal to V. Of course, we concluded in exercise A that in the long run we don't want any waste. So it would be ridiculous if we can adjust the number of units of labor to have more than 5 units of labor in place, because they won't add anything to our production. So a profit maximizing firm will never choose more than 5 units of labor, so it will always find itself here, where the cost function is equal to WQ over 10 plus 10 times V, and the production will always be smaller than equal to 50, because it's the amount of capital puts an upper limit on it. So this is our cost function. Given that we have the cost function, easy to calculate the average cost function, which is simply C divided by Q, and the marginal cost function, which is the derivative of the cost function with respect to Q, which in this case is W over 10. So these are the short run, total, average, and marginal cost functions. And this completes exercise B. Then in exercise C, we are given that the cost of labor is 3, that's the wage rate, and the cost of capital is equal to 1. Calculate the firm's long run and short run average and marginal cost curves. So we continue in a similar vein. In the long run, both labor and capital are flexible. So we continue with the expression that we derived in question A, plug in the values for V and W, and the long run cost function equals 3 over 10 plus 1 over 5 times Q, which reduces to Q over 2. And in the short run, capital is fixed at a level of 10. So the total cost of capital is equal to 10 times 1. And the total cost of labor as a function of the production is 3 over 10 times Q. And in the short run, we will never produce more than 50 units because the amount of capital of 10 units serves as a bottleneck to production.